Okay, here we are. Okay, so what I did so far was I basically just like coded out, like the beginning, just initializing a school, setting the attributes. As you know, right, the first argument, if we're inside of a class, is always self, right? And then we're passing through these various arguments. You can see like this lines up with the test. So here, right, we are using, I gotta think of the right word. I don't know if it's called splatting or like mass assignment. I'll find out the right word for this. But the 2 stars, right, and which, as you know, takes these attributes and is the same as doing like dbn equals this value, name equals that value. So we pass that into the school class, and then it assigns those attributes here, right? So it's literally self is the new instance, and then dbn is the value that's coming through here. And then what I ask is just, okay, well, if we do that, kind of put the breakpoint here. Let's run the test. If you do that, and then you see the instance, the school instance, we're passing through this data, so we should be able to do something like school dot name and get back that attribute. And here, I guess what it's saying is, and all the attributes that are assigned should be like school. If you just want to see all the attributes, you can do the dot dunderdict. So this kind of shows you the data in the instance, right? Here's our instance. And then the dot dunderdict shows you the data inside of it. And then you can do, this is just a dictionary, right? This data type is a dictionary. So you can just do dot keys to see like what kind of attributes are there. Questions about that part? Or just initializing an instance, getting the attributes with this dunderdict thing, and then it returns a dictionary of the attributes. Then we, here we're saying, okay, well, I want to make sure an instance, that this instance has all those attributes. So I do that by looking at the attributes.keys. All right, and then the next thing, this is actually something I don't think we covered yet, which is, this is an attribute that we're putting on the class. So I'll show you how this works. You can basically, if all of the instances have a common, have the common value, right? Then what you can do is you can set a class attribute. So here we're saying the city is New York City. All right, and now here's what I think what we'll see. Let's put a breakpoint here. So we're going to get to this test. Here's what we'll see. If we have an instance, right, let's just create an instance again. And you look at dot dunderdict. Notice there is no, you don't actually see dot city as one of the keys, I don't think. Let's take a look. If we do dot keys, right, you see that? It's not anywhere, okay? Because what we're doing is we're setting, we're not setting an attribute inside of a method, right? And where we're doing like self dot, right? Remember, this is self refers to the instance. So not doing like instance dot city equals a city. Instead, we're setting this attribute outside of a method, outside of an instance method to be particular, precise. And because of that, this is actually set on the class. So if you look for school.dict.keys, there's nothing that says city here. But if you look at the class dot, I wonder if I can do dict here dot keys, right? You can see it already. Here, this class has an attribute called city on it. All right. And notice, right, it also, that class is also what gets where our methods are defined too, which kind of feels weird. Just to blow your mind a little bit more, if you look at this school object and you call .city, it does return, right, New York City, which is kind of weird because we just said it's not here, right? It's not here, but rather it's on the class. So you can see what Python's doing, essentially, is that when you call, let me just share this. When you do something like you have this school instance, right? And you ask for like dot city. The first thing that Python will do is look for it on the instance. But if it doesn't find it, then it will look for the attribute on the class that like gave birth, that produced this instance. Okay? So Python knows what each instance came from, right? Because we know, like for instance, the type here is this school, right? So we'll look to see, hey, okay, there's no attribute city defined on the instance. Is there an attribute defined on the class that produced this instance? And the answer is yes, and so it returns that value. Yeah? Just to go a little bit deeper with this, if, say, there's a conflict, like for instance, right here, we have this school. The school does not have any attribute that says city on it, but the class does, right? The school class does have an attribute called city. And because of that, if we do an instance.city, it gives you back New York City. If instead we override it, right? Let's say it's like Chicago. And now I do school.city, it's going to be Chicago. So why? Because Python is first looking to see, does the attribute live on the instance? In this case, it does. Right? It lives on the instance. So it stops and returns the value. And it never gets to the place of it never needs to look at the class and find, oh, no, that's not on the instance, but it's on the class, it's on New York City, right? So, what's kind of the takeaway? What Python does when you call something like school dot whatever attribute, it first looks to see, is the attribute on the instance? If it isn't, it will then look to see if it's on the class that produced the instance, and it will return it. If it doesn't find it on either, it breaks, right? If it says you call something like school.city and it is on the instance, then it just returns. It doesn't look any further. It returns it. Okay? Questions about that? So what we did was we set an attribute on the class initially, and this way, like kind of by default, every instance will, if I call school.city, by default, every instance will return like New York City.
And if you change the New York City to Chicago, every instance after that will report Chicago instead of New York City.
Right, exactly. Yeah, exactly.
But can you put that as in the init? Can you do this self dot?
You could. Yeah, you could. Sometimes what you'll do, so that, you could do this. You could just put self.city equals New York City here. Lots of times this kind of stuff, I think stylistically you would put up here. More often what's the case is you'll see it with restrictions. Like for instance, you'll say we have a car. What you'll see is like available colors, something like that. And then it'll be like, here's the list of available colors, red, green, blue. And then when you create it, color, it will only allow, it will be only, say raise, choose available color if color not in, right? Car dot available color, something like that. Right, so this is a way, lots of times you'll see it kind of like this, where you're saying, hey, we produce these cars or whatever, or say we have a product, it's only available in these states. And now someone tries to, sign up who's in a state we don't serve, and so we raise an error or something like that. So lots of times you'll see it more like this. I think here also it's kind of saying like, hey, this is just kind of jumping out. It's more like for you readability purposes of, hey, like this is how this is something common to all instances, is this attribute. All right, so it's a little bit of a subtle point. Let's do the next thing. Okay, so here, I raised this point, I think, in the last class, but these methods, like you want to ask yourself, a method on an object is you, last time, just asking questions about the instance, right? Like you're asking questions about a particular school, and you're saying, hey, what is like the total score here? So in this case, right, it's going to take the reading average, the math average, and the writing score, seems like, and add them up, right? So the total score, so basically we want to write a method, def total score, self, right, and return the sum of self.reading, self.writing, and self. Whatever it was, math? Yeah, math. Okay. So basically take these are all, it's important to note the different, like these are attributes, they're not methods. So I can just call self.reading average, and it directly returns those values. And then let's run the test. Just want to make sure there's no breakpoints. Doesn't look like there are. So we see we have 2 passing. This does not look like it's one of them. It says sum takes at most 2 arguments and 3 were given. So this should be a list in here. That's my mistake. So if I'm going to add up these 3 things, I should wrap it in a list. But you could see the error. Sum takes this, and I can see where it's occurring is in this total score method, line 17. So we're right here. Let's run it again. All right, and now we're good. Okay. Let's do the next thing, the average student attendance, right? And again, like, one question you may have when you're going through this stuff is like, why do we even go through the bother of creating these instances anyway? Like, why don't we just use a dictionary or something? The reason why is because you're writing, these methods are attached to this object, right? And so you're kind of defining a set of questions that make sense to ask a school. Like, hey, school, what is your total score? That's different when we include other objects. Like, that doesn't really make sense for, say, like, a principal of a school, right? Like, hey, principal, like, that doesn't totally make sense. You can maybe think of a way that potentially it could, or let's say if it was, I don't know, maybe like maybe like a school nurse. Maybe that's a good example. Like, what's your total score? Like a nurse, you'd have other questions that you would ask the nurse. So this is a way of like grouping, methods and saying this method is associated with this kind of object, and then things about the nurse, about like maybe how many patients she saw, or whatever, like how her hours, availability, like those are other questions, right, for the nurse. So this is a way of kind of organizing your methods and saying this is what a school can do, right? Like this is the kinds of questions you want to think about when you have a school object. What's its total score? Like that's pretty valuable, right? Let's go to the next one. The average attendance, right? So for the average student attendance, we'll just take the self dot total students and multiply it by the attendance rate, and we're good. All right, average. I won't do all these. Average student attendance, pass through self, return the self dot total students times by the self dot attendance rate, and we should be good. Okay, cool. Well, let's just do the last one to be completist. Okay, so the max score is def max score, and then we probably take these 3 scores. Instead of adding them, we'll just get the max of these 3 and return it. And that passes. All right. Okay, so now let's move on to, I guess, something a little more interesting, which is these tests. So, right, so now again, like you're kind of switching context and you're thinking, okay, like we're not about, one individual school anymore, but rather building a collection, I suppose. So we want, first thing is, I think we need to write a function called build instances, something like that. Test build instances creates these instances with the selected attributes. So let's go inside here. This will be in the query schools, and let's just put a breakpoint here. It might be annoying with the debugger. So this time, by the way, notice I'm doing PyTest, and here I'm specifying the name of the file that I want to run. This way it doesn't run all the files, but just, that one. So here we'll do test query schools, and I can just focus on this one. And what I'm looking for is like, what are my school dictionaries? And you can see there's a bunch of them. Maybe we look at just one of them. And, what do we want to do? We can say, for school dict in the list that we want to, let's say this is my schools or my instances, and you can, create a school instance and pass through, right? I can, this is not defined, so I'll probably have to, from the school module, import my school class, and then pass through a dictionary, right? So if I have a dict school dict equals school dicts square bracket 0 school dict this thing, and I'm going to pass it into a school. So what's the easy way to do that? Do the star thing, and that'll be db, and we'll see. This might break. I think we saw that it did break. So let's do this school dict. And it breaks. Okay. Why does it break? Because we're passing through this dictionary has this thing number of test takers, which is not one of the arguments in school. Okay? So we need to make sure we're only passing through the arguments that make sense. So how do we deal with something like this? What we can do is probably like filter my dictionary to say, okay, if these are my, do I have a list of attributes? These are my attributes. All right. Then what I'll first do is, say only get the key, filter the dictionary. So let's take a look at it, school dict. And remember, we've actually seen this problem before. If these are my keys, we'll say for k comma v in school dict dot items, right? And only return the key value pair if the key is in the list of keys. And it's not going to work because it's just because of the I'm in a console. I forget, there is a way to fix it, but I don't know how. Or we can use get. Yeah, that's true. You could use get. That might work too. Let me think about that. I mean, I think it would work. I'm trying to think if there's any issues with it. But this should work fine, So what we'll do is this will be my selected attributes. All right? And then we'll pass the selected attributes into the instance. Notice that this thing is complaining, right? Why? Because we didn't import it. To say from school, import the school class. Let's put a breakpoint here. And finally, we will append this. Okay, so what are we doing? We're starting with a list of dictionaries, right? And we're going through each one of these. So we have this kind of school dict thing. The problem is these dictionaries sometimes have too many attributes, so that when we initialize with these attributes, it complains and it says, hey, you're trying to pass through an argument I forget what it was, number of test takers, that our class does not take anywhere, right? There is no number of test takers here. So the way we're fixing this is we're first saying, let's only select the attributes that are in this list, right? Then pass that thing into my school class. So this will create a new school. And then finally, we're going through each, a whole list of dictionaries. So for each one of these dictionaries, create the school instance and then add it to the list, right? And then finally return that list of schools. So and this is going to, where is that? Oh, in query schools. Test query schools. This will take me right here. So let's put a breakpoint here. Okay, so we are here. So we basically, here's the selected attributes. We have these build instances thing, right? Which basically goes through each of the dictionaries, selects only those attributes, creates a new school from it, appends that school to a list, and then returns that list of schools. So if we have this and we look at schools, you can see we have a bunch of school objects. You see that? A bunch of them. In fact, this is just a list. You can put any kind of object you want in a list. It can be a string. String is a kind of object. It can be a dictionary, a list of dictionaries. Here in this case, we have a list of objects, right? And so if you select the first one, you can do, here's, the first school. And you can ask the same questions you would ask normally, what's the name? And then if you want to say get a list of all the names for school and schools, print the name or something like that. So anything like that will work fine. So this should work. Well, let's just see it pass. We took out the breakpoint. Cool, so we got that one passing. And now, okay, here's the next question. Get the largest total score from schools. So we want to find the school. I think I'll only do, maybe this is the last one I'll do. Find the largest total score. I think I meant school. Yeah, score. What school has the largest total score? Okay. So think about this. We have our list of schools. Let's put a breakpoint here. Right? So we have our list of schools. These are all our school objects. So for any one of these schools, we can ask the question, right? Hey, what is your total score? Right? I can do school.total score. So for any one of these, I can ask that question. What is your total score? So now what I can do is probably, so I think I have to do this here. Take the list of schools. Let's write this out here. So this is going to pass to me. All right, so we still have that same list of schools. And what I want to do, I think, is sorted. Do sorted. And now this takes schools, and for each instance, I want to ask the question, school.total score, something like that, and then take the first one. And this will be reverse equals true. So I want to get my schools, sort my schools, and then get from top to bottom based on the total score. So that's what this is doing. I'm just going to show you, hopefully, that it works, and then we can break it down a little bit more. All right, so let's put a breakpoint here. That didn't work. Did this not hit this? Let's see. expected one argument got 2. Oh, this should be key equals, guys. You all forgot that. This needs to be key equals. I think that's it. Key equals. Is that it? Try that. Okay, that worked. So let's take a look. So now we have these sorted schools. So again, it's a whole list, but this time we sorted them by what? Well, let's take a look. Sorted schools, square bracket 0. If you look at the total score, it returns what seems like a high score. Let's go to the next one to see if it's lower. Right? This seems like it's sorted. I went to the first school, asked for the total score, went to the second school, asked for the total score, right? And now the test says, well, that school with the top score should be Stuyvesant or something like that, right? So what are we doing? We're using, remember this method, if you have like a list of names, you know, and Bob and Sam and say, let's do Sa, so B, A, and C. A, B, C. Okay, so let's say we have a list of kind of names, and we want to sort them by the last letter. Well, remember kind of how we can do that is sorted names, key equals lambda, the name colon, name -1. So this is what you're sorting by for each element in the list, right? And because of that, we have A, B, C, right? So in this case, we're doing the same thing. We have a list of objects, and for each one, we're calling this thing total score on each one of them. And then we're just going to take the first one in the list, right? And we're doing reverse equals true because we went from highest to lowest, not from lowest to highest. All right, and we could also do just get the last one in the list and not do the reverse equals true. Right. The other thing you could probably do, I think, is maybe max works the same way, right? So that's a good question. Like, what if you do, instead of sorted, does max take this lambda thing? So here, if we think about it here, this should give us the highest last letter, which would be ABC. And that seems to work. So you could do this as well. And now you don't have to, you know, you can just, this one returns 1, so you don't have to select the last one, it's only returning 1 object. So go through the list of schools, continually ask this question, what's the total score, and return the object with the top 1. And I think that would work too. Let's do it here first. We'll do max schools, comma, this thing. Key equals lambda school, right? And it seems to work, right? Let's do dot name and Stuyvesant again. All right. And so this is similar logic, right? Like kind of ask the question again and again and again for a list of schools, what is your total score? And then take the average, right? Calculate the average. Add them all up and divide by the numerator. So these last two I'll leave for you guys, you all to complete. How does this feel to you, these ones? I can send this out in Slack if you want to look at it.
I think if we pass that in the init method star and passed in the build instance star, it would be very easy code, one line code for all creating all instances. If you remove from init everything and just put self and star.
That is true, and that's a fair way to do it.
And everything is just one line code for creating instances.
That's true, right? So what Pally's saying is, you know, we could replace this. Right, with like def init self star quarks, right? And then so this will take the keyword arguments, and I think you'd have to, and it return. So if you pass through, if you do something like this, school name equals Stuyvesant, and let's say the borough equals like Manhattan, then over here it will come through with this star quargs. It will turn these keyword arguments into a dictionary, right? And so what you'll have to do then is kind of like go through, what you might see is like, okay, we'll go through these items, this list of items, like call for k comma v in quargs dot items. There's different ways you can do it. I guess you could do like self. Yeah, there's different ways. Probably the easiest way is you could just take this list of quargs. It's a dictionary, and you could just do self.dunderdict equals the quargs, this list of keyword arguments, right? Because if I pass through this dictionary, now I'm basically just going to set that dictionary equal to my dunderdict thing, and that will work, I believe. Let's take a look. Let's try it.
Or update maybe.
Maybe I have to do update. I don't know. Let's find out. I should be able to play with this thing just by. In this case, I don't really even need a console because I'm only really using this one file. So I can do Python 3-i school.py, right? That will run this and kind of put me at the end of the file. And now I could do create a new school. And if I do like name equals Stuyvesant, borough, Manhattan, and here's my school, that seemed to have worked. So that is a way of doing it. So why wouldn't you do something like that? Well, one is, this isn't very like documenting, like it doesn't, if you wouldn't think about like reading the code base, and this is a little, like just looking at this, it's like, well, what are the attributes of a school? You can't really tell until you initialize one, pass through some data. But just looking at the code base, which is how you're going to get your bearings a lot of time, it's hard to tell. So that's one downside of it. Let's go through some downsides. Another downside is oftentimes you want restrictions on the data. Like you don't want to be able to pass through anything because maybe this attribute actually belongs in a different class, right? Like you want like, hey, this is what we're passing through, and like this is how we're handling it. So like putting some sort of limitation, you can almost think of as like validation almost of the data, but like restricting the data is good because that's what keeps it organized and keeps certain data in one file and another piece of data in another file, right? So there are ways to deal with this too. Like you could kind of now put remember I talked about using like a class to put a list of restrictions. You could do something like this. We'll say, okay, well, these are my like attributes. And we'll say, okay, we'll assign this, but, raise an error if quargs, if one of these keys is not in these selected attributes. You can think about that, right? So that's oftentimes what you'll see. We will go through that. I'm not going to go through it now, but you can think through the code for how to do something like that. Yeah, and then Pally, I liked that way. What I just saw. Let me show you the other thing you're talking about. See, the other solution Pally had was, okay, well, let's just keep our old. I'll comment. I'll comment this out. Let's keep our old way of initializing this, and now to actually build this whole list, I still like kind of selecting the. This is essentially what we did. Select the attributes first, which is what I like, and then initialize the school. The only difference is, right, like performing list comprehension which you could do in 2 steps, I suppose. It's not a huge deal either way. All right. So what would I do now? So I think we're basically, unless there's other questions, I'll wrap up the, this lab review. So that leaves you all writing these 2, if you haven't written them already. And I'm happy to send you this. Okay. The other thing then to do is go back through the discussion questions from the last class. I want to give you guys maybe like half an hour to both, half an hour, 40 minutes to both go through these last 2 and / what we went through, and then also the discussion questions with your partner. And then we can, go through them and move on to the next component. All right. Questions before I put you into breakout rooms? You guys get why we use objects? Objects are associated, it's data coupled with behavior. And by behavior, I mean methods, right? So objects are saying, hey, this kind of data about a school, I want to, couple it with these questions. And this way, when you think about a school, this is the stuff you should be asking. Like, it's almost like jogging your brain. Objects are written for developers to read, like to make your lives easier. Then you can write all the code without objects. But this is supposed to make your lives easier. Yeah, so then, let me give one second. Let me stop sharing.